Hi there, I'm Katie and I'm a glaciologist at Aberystwyth University. I research glaciers and I'm particularly interested in valley glaciers. Valley glaciers are found particularly in mountain ranges such as the Alps in Europe and the Himalaya in Asia. And glaciers are really interesting because they're really key indicators of climate change. So for a typical glacier, we typically expect it to gain mass in winter, so snow falls on the glacier and that compresses over time to form the glacier ice. And then contrary to the mass gain in winter, the glacier will also naturally lose mass in summer through the sun melting the ice surface. And in a glacier that's perfectly in balance with the climate, the winter mass gain will approximately balance the summer melting. But what we're finding with warming temperatures, warming air temperatures with climate change, is that the glaciers are melting more in the summer than they are gaining mass in the winter. And this is causing them to shrink, so they're losing mass overall. And this can be seen both with their terminuses retreating and also the surface lowering. So the size of the glaciers is shrinking over time, and this can be seen looking at historical imagery. And what's really crucial at the moment is that as the climate is warming, the amount of meltwater at the moment is increasing, running off these glaciers. But in the long term, it's going to decrease and potentially disappear. And that has really important impacts for people downstream who rely on this water for their livelihoods, whether that be for drinking water, for watering their plants, or perhaps for sanitation. And I've just been involved in a project on Khumbu Glacier in Nepal. Khumbu Glacier flows off the flanks of Mount Everest, which you may know is the highest mountain in the world. And the way we wanted to look at the impact of climate change on Khumbu Glacier was to see how the temperature of the ice varies over time. So ice obviously is cold, we all know that, but the temperature of ice can vary quite a lot, from maybe -1 or -2 degrees, which is what we call warm ice, down to -20, -30 degrees, which is cold ice. We wanted to look at this for Khumbu Glacier, and to access the interior of the ice, we drilled boreholes across the glacier, and we did that using hot water. We converted a car pressure washer so that we could drill the borehole with a jet of hot pressurized water. And we wanted to access deep inside the glacier because near to the surface, the temperature of the ice varies following the surface air temperature. So warmer in the summer, colder in the winter. But once you get past about 20 meters into the ice, you start seeing the long-term stable ice temperatures, and that's what we really wanted to access. So once we drilled our boreholes, we inserted cables with sensors attached, thermistors in particular, to measure the temperature. And we put these down, as many of our boreholes as we could, down to about 200 meters into the ice. And we left those sensors there as long as we could, given us about 2.5 to 3 years of continuous measurements of ice temperature. And this is going to be really useful for us because it will allow us to see if the temperature of the ice is changing over time. And if the ice is getting warmer over time, then it may well be that the warming climate is having an impact on that and the glaciers might melt faster in the future.